Hello, and welcome back to another episode of Joe's compulsory extracurricular state weather video. So, I just finished up my first semester of college, and I'm back home for the holidays, making yet another weather video. And this is my second type of state ranking weather video. The first one just regarded weather as a whole for each state, but now I'm considering weather during the winter for each state. This is quite relevant because there's a blizzard going on right now. Yesterday, got down to -10 with a -30 wind chill. This is so bad that even southern Florida was having temperatures in the high 40s. Like, for Miami, that's pretty unheard of. So yeah, there we go. So you may be wondering, so like for summer weather and winter weather together, I just considered the temperatures and the ranking by bestplaces.net. This time I completely shied away from that. I'm only considering temperature and snowfall quantity and generating my own formula and reporting on what I think is the best way to combine this information into a ranking. I'm not just looking something up and then posting it online, because that's just goofy goober type of thing to do. So, if you're wondering for actually how I did this and how I ranked these states, you came to the right place. I don't know what else you would be coming here for, so good job. So there are basically two parts to this whole shebang, which doesn't sound like a lot, but the second part may wrinkle your brain a little bit if you're not mathematically inclined. Anyways, the first part is converting all the temperatures to Kelvin so it's on more of an absolute scale. I could explain now why it's relevant, but I'll do it later, so it just makes more sense after you know the whole context. So the second part is something called, or that I call, a snow punishment coefficient. I could have named it after myself narcissistically, but I'm better than that, you know? So the snow punishment coefficient, I'm not gonna lie, it's too complex. Too much random mathematics going on in there. It's not even high level mathematics, it's just a lot of low level mathematics. But who cares about that? I'll just kind of break down generally what it means and what it stands for. Then I'll break down specific components of this formula, and then I'll put those components together into the specific context of what this coefficient is trying to achieve. Okay, so in general, I just wanted some way to quantify how snow itself affects your life, and just some way to measure how much it affects your life. And after wondering for quite a while, actually, I settled on how much time it adds to your workday. So something like scraping the windshield of your car and heating it up before you go out, or going out, heating it up, coming back, and then before you go back out again, how long you have to wait before your fingers don't freeze off and the ice on the windshield is even scrapable. And like commute time, it adds to commute time because you can't really drive as quickly, you can't turn as aggressively. Not that I'm trying to Tokyo drift onto a main road in my city, but it's something to consider. And the last thing would be shoveling the driveway. That took me too long to remember. So really we need some way to compare all these states together. And to do this, I decided to set some sort of average where you allot some sort of amount of time for the average snowfall, how much the average snowfall increases time, and just scale it by how that state's snowfall compares to the average. So for example, heating up a car and scraping off the windshield. I gave that 5 minutes. That sounds pretty conservative, but for some places later on the list with a lot of snow, it would be absolutely brutal if you put maybe the more realistic 10 or 15 minutes. And honestly, not very representative. And honestly, that's part of mathematical modeling. You need to be tweaking things, even if it's not perfect. It's just so it, in general, fits the idea. It's just a model. It's not actually a rigorous sort of algorithm with relevant information that's like tangible. You just need an idea of what's going on. Anyways, I gave about 30 minutes for scraping and shoveling the driveway. That's probably pretty accurate in my experience, because I think I have pretty average snowfall around these parts. It takes maybe 30 minutes. And then I didn't know what to give for commute time, so really I had to look it up. Apparently, for about the average snowfall, it adds 7.6% to your commute time. Seems like someone pulled that straight out of a hat, like a magician pulling a rabbit out of a hat, you know? But I'll roll with it, because at this point, I'm more concerned about getting something on the table than having something completely accurate, because the complete accuracy has already been thrown out the window, and it's been gone for a while. So now, you know the specific components. Now for the actual context of this coefficient, really what it is it's the time it would just take for commuting and working. Let's just say 1 hour total commute time, about like round trip, plus a 9 to 5 work day. It would be 9 hours divided by 9 hours plus the time added based on a specific state's snowfall and the averages and the average times I provided earlier. So this snow punishment coefficient, aka SPC, if you have an SPC of 0.8, really what that's saying is that your day would be 80% of what it is if you didn't have snow on that day, on average. So, it's obviously you want a higher SPC, and there are a couple states on here. It's not any spoiler, like Hawaii, Florida, Louisiana, these pretty warm states in the winter that didn't have snow, so their SPC was actually 1. But for the states with a lot of snow, this SPC was brutal. The worst one being about 0.77 based on my most recent calculations. So now, it should be more clear why I use Kelvin instead of Celsius. With Kelvin, the actual temperature value is always greater than or equal to the value found by the SPC times the Kelvin temperature. Because if you'd done Celsius, you'd be considering negative Celsius temperatures. So then scaling that by a value less than but close to 1, it would actually be increasing the value because it's negative, bringing it closer to 0. Yeah, and I'm just not a fan of that. I think it's better in my brain to sort them as all numbers kind of in the mid 200s range after the SPC times Kelvin computation. So now, we have everything we need to rank these states. It's time to get into it. So first I'd like to mention that this value itself, SPC times Kelvin statewide average temperature in the winter, is pretty arbitrary and also pretty meaningless. And as such, I will only be providing the rankings themselves in this video, but I will be providing also a screenshot of this spreadsheet at the end. I would provide the spreadsheet itself, but I'm not sure how you'd include that in the description of a YouTube video. So, there you go. Enough rambling. Let's get into it. First, the 10 best winters. Number 10, Arizona. Number 9, Alabama. Nice, southern state. Number 8, South Carolina. Number 7, Mississippi. Number 6, Texas. A lot of these states have brutal, humid summers. So if you're jealous of them and you live in a place with a more temperate summer, don't be. Their summers are probably brutal and they already put in that work. Now they're reaping the rewards right now. I was being redundant, don't worry about it. Number 5, California. Okay, I know some Californians may be slightly offended by that, but I will say now, if you live on coastal California, that's better than California on average. And thus you should be considered better. Honestly, it would probably land somewhere just below number 2 on this list. And number 4 would be Georgia. So I kind of forgot about Louisiana, but Louisiana is number 3. And number 2 is Florida, which is pretty common sense. If you only consider southern Florida, like the Miami area, it would probably be just about equivalent to number 1 on this list, which is quite obviously Hawaii. Hawaii is the only fully tropical state in the country, so it makes sense why it has the best weather during the winter. So now, for the top 10 worst winters, we have number 10, West Virginia. Now, West Virginia was heavily detrimented by the quantity of snow it receives in the Appalachian Mountains. West Virginia is the worst ranked state by quite a long shot for states with an average temperature above 0 Celsius. It's pretty surprising that the average temperature is above 0 Celsius, but they also get 50 inches of snow per winter. Don't ask me. Number 9 would be Wisconsin. Number 8 is North Dakota, which is actually the second coldest state on this list, besides Alaska, of course. And that's just kind of surprising. It's number 8, despite being the second coldest state. Number 7, New Hampshire. Number 6 is Minnesota, the third coldest state on this list. Number 5 is Maine. Number 4 is Vermont, the worst of the New England area. Number 3 is Wyoming, the worst in the western contiguous United States. Number 2 is Alaska, actually. You may be wondering, what state could possibly be worse than Alaska? I mean, Alaska has the coldest temperature on this list by a large margin. So that means this state must have a ton of snow to make up for that, and in fact it does. The number 1 worst winter can be found in upstate New York. I say upstate because New York City itself is not really representative of this. And maybe you should consider something more like Boston or Baltimore, so maybe an average between those, if you want a better idea of what New York City itself is like. But upstate New York, it really pertains to the geography of New York State as a whole. And it has brutal amounts of snow. Places like Syracuse, Rochester, Buffalo, etc. Due to the lakes, Lake Erie and Lake Ontario, and the lake effect snow that affects them. So, that about finishes up the rankings. I hope you've enjoyed, and thank you for watching.